Alright, part B. Using correct units, explain the meaning of the definite integral from 0 to, this is a 40, let me write that in there, of the absolute value of v of t dt in the context of the problem. And then approximate this value using a right-Riemann sum with 4 subintervals indicated in the table. So either you memorize that the integral of the magnitude or absolute value of velocity is distance traveled, or you notice that this this absolute value of velocity is speed, and if you integrate speed, you get distance traveled. If you integrate velocity, you get displacement, but displacement keeps track of forward and backward movement. They cancel out. In this, forward and backward movement are all accumulated. So in here, first thing I probably need to explain the meaning of this. So the integral from 0 to 40 of the magnitude of v of t dt is the distance traveled from t equals 0 to t equals 40, and it's going to be measured in meters. Now, you know distance has to be measured in something like meters, so you can sort of guess your way there, but what's really happening is this. The velocity, this magnitude of velocity, is measured in meters per minute. This dt is measured in minutes. The minute units cancel out, you're left with meters. Alright, second part, approximate that value using a right-Riemann sum with 4 subintervals indicated in the table. So I have 5 values. My first subinterval is going to go from time 0 to 12. Second one's going to go from 12 to 20. Third one's going to go from 20 to 24. Fourth one's going to go from 24 to 40. And I'm using right-Riemann sums. Basically, those are 4 rectangles. So let me write this out. So this integral from 0 to 40 of the absolute value of v of t dt is going to be approximately, the first rectangle is 12 units wide, and since I'm using a right-Riemann sum, I go to the right side of the interval and say it's 200 units tall. So I have, first one is 12 times 200. The second rectangle goes from 12 to 20, so it's 8 units wide. And the right side of that interval is 20, so I get that it's 240 units tall. The third rectangle goes from 20 to 24, so it's 4 units wide. And I go to the right side and see that it is 220 units tall, because I'm doing the magnitude absolute value. This negative 220 becomes a positive 220. And then the final rectangle goes from 24 to 40, which is a change of 16, so that rectangle is 16 units wide. And it is, on the right side of the interval, 150 units tall. And so I just go through and do the work. So 12 times 200 is, approximation, 2400. 8 times 240, let me do that work. So 8 times 40 gives me 320. 8 times 2 gives me 16, so I get 1920. 4 times 220 gives me 880. And 16 times 15, well, I can do this, 16 times 150, I can do this many ways. I could do like 16 times 16 gives me 256, and then 2,560, then take off. But I'll just do it the long way so that we can all know it's right. So 150 times 16, 0, 6 times that gives me 30. 6 times 1 is 6 plus 3 is 9. Put in 2 zeros. 1 times 5 is 5. 1 times 1 is 1. And we end up getting, that's going to be 2400. Okay, so plus 2400. And now I just go through and add them up. So 2400 plus 2400 is 4800. And, ooh, this is nice. 880 plus 1920. Well, 80 plus 20 gives me another 100. So that brings us to 2000 plus 800. So I get 2800. Then I add these up. 2000 plus 4000, 6000. Plus 800 plus 800, 1600. So I get 7600. And the units on that are in meters.